Welcome to the talk. It's about HDLAgent. It's an AI agent to enhancing hardware design. This work is by Mark Sakharov and Farzaneh, two of my students. My name is Jose Renaud. So a little background, this is work by the MASH group. As I said, two of my students are working. I'm having more students starting to work, but Mark and Farzaneh is the one leading this work. So what is the goal? The goal is to improve chip design productivity using LLMs. And this includes coding, verification, optimization. This is not about improving the EDA tools with AI. So there are two ways that you could interface with LLMs. You can have an autocomplete copilot like a human drives the coding. This is not, it's a worthy goal. I really think it's a viable alternative, but this is not what I'm doing. What I'm focusing is no code approach. Is like the LLM drives the coding. And it's because we think that it has more potential for improving productivity. So what is the current state of the art? You use something like GPT-4. So you write simple tests, system Verilog assertions, simple combinational only modules. That works. That works fine. Now notice the common word here, simple. System Verilog assertions are short too. So simple things work. What fails? You try pipelining, you optimize design, you have complex logs, any design task. The main focus I'm going here is you have any HDL beyond Verilog and you want to extract documentation. There are several issues that don't work well. To explain a little bit quickly how to make it, the flow works, I'm going to use Python instead of Verilog. So imagine you have a problem that is you want to parse a markdown file and extract the headers. So you give the instructions. So you try this with GPT-4, GPT 3.5, and it fails. So what are the typical things that you do as an agent or when you are working with LLMs is that you have a phase that's self-reflection, which is mostly LLMs talking to LLMs. That can be the typical explain step by step, or you say you're a professional programmer, and then you tell them, can you please debug the previous code? So it's several steps, but it's LLMs interacting with LLMs. And you can put some context if you want. Now, after that, you might have a step by step, you have more like a definition or a specification of the problem. You try this and it still fails. So what do you have to do? You put a human in the loop because the spec might not be good enough. So what you can have problems can be LLM specific, misunderstanding, or undefined spec. For example, in this Python case, you have to say ignore headers in code sections. So you were having a code section with hashes. You were thinking it was a header, but in fact it was a code section. And also indentation. Now in theory, these the LLMs should have figured out, but the reality is what it is. But there are some other parts that is undefined spec. So I wanted the strings with a carriage return. It was returned without. That's not part of what I wanted to do. So the human will have to iterate, bring the spec in the same way that it iterates with the program. We do this type of flow. But so usually there is this self-reflection, there is the context, that is the retrieval augmented generation, the RAG part. But then there is another key part that is the grounding. So if you have a tool, a compiler, that is what we have in our case, that it can test the correctness of the generated code, then you should ground it and catch mistakes, like maybe there's a missing semicolon, maybe it's an incorrect type assignment. So what you do is you iterate the code until you fix the code, and you can provide some hints on the fix. This is not so important for Verilog, but this is very important if you use another hardware description language. You can do more grounding by generating tests and then iterate on the test. I'm not using this on this evaluation. We're working on that. If you clone the repo that we have, it already has this included, but we don't have it because it's not working very well. So what is the thing we are doing with HDLAgent? So it's an AI coding agent for hardware. It does self-reflection, it looks at context, providing examples, and it does some grounding. So how does it look? if I look at the success rate, this is a couple of benchmarks. HC is for pipelining, HC for combination only, HP for pipelining. If I do GPT-4 Turbo, Verilog, decent, Chisel, not so good, but it does. PyRTL, not great. And this version, this is like a few months old version of GPT-4, it didn't know about the SLX, so it didn't work very well. So if you put context and explain the language, then suddenly you're starting to behave better with the other description language. For Verilog, it doesn't matter so much because they already know. If you add the fix in the compiler error warnings, so it gets even better. If you provide examples, even better. So if you eyeball this thing, you notice that more or less, no matter what's the description language, you are able to get the same quality. I didn't fine tune the model, and I get the same quality. So one of the key contributions of this HDLAgent is that you can now do knowledge transfer without needing to fine tune. So you can use any LLM around, iterate with the HDLAgent, and it gets some quality of results equivalent with a HDL that is brand new, never used in training. So how does it compare across HDL? Well, there are different LLMs. We tried GPT-4, Mixtral, Gemini Pro. Usually the worse the LLM, that the least knowledge of the language works, it works also for Verilog. So you can do knowledge transfer even when you don't have Verilog, it's just programming in general. There are many issues, no time in 7 minutes talk, but here what we are showing is the success rate, how it decreases as the problem size of the output increases. Being verbose in the input is not a problem, as long as it fits in your context. Creating more complex outputs, that's a problem. And this is nearly a linear decrease you average across the LLMs. Now, there are many things that there is no time to go, but let me give you a little example. That is the LLMs need compiler errors. So what happens many times in PyRTL, they mix Python operators with PyRTL operators. Like here, there is a shift right, but this is not correct. If the compiler gives a warning saying, oops, this is a shift for Python, not the PyRTL operator, this is the PyRTL operator. You iterate and it gets fixed and it's not a problem. So if you put errors that you locate the line of code and you give a hint of what's the problem, this can get fixed very easily. So you need to, that gives you a lot of freedom. So conclusions. So I'm working with the LLagent, that's the repo, it's open source already. The code is paper driven, so it's not so quality for usage, but we are fixing it, we want to improve it. We are creating benchmarks, because if you want to evaluate different HDLs, you need to have benchmarks. But you are welcome to do pull requests. Anyway, so that's been all. You have any questions, go for it.